turn to review two important pieces of evidence which can be used to motivate the use of the flipped classroom approach. As an introductory note, let us say that although it is subject to contention, this new approach to teaching seems to have been conceived by chemistry teachers Aro Sum and Jonathan Berman, who started using video recordings and screencast software within secondary school in 2007. It is thus a fairly recent innovation which is however catching speed at a fast pace. It has two main elements: conventional lectures replaced with online video or audio files to be watched at home. And second, in-class lectures which involve active learning in order to fully exploit the possibility of an interaction with the students and between the students at the point when it can actually take place. The traditional lecture is perceived at its best as a fun reading of the book to the students, and flipping it is a natural way to make a much more efficient use of the available resources to both the teacher and the students. Probably one of the most compelling pieces of evidence that vindicates flipped classroom is a study published in Science in 2011. This involved a large enrollment physics class where a total of 538 students were divided into two groups, treatment and control group. During the week of the experiment, the treatment group received experimental instruction in the following format. They were asked to read certain chapters of the book before class, and in the actual lecture, active learning was implemented involving elements like clicker questions, problem solving with a student discussion, and targeted teacher feedback. These sessions were imparted by an experienced instructor. The control group followed more or less a standard lecture. At the end of the week, both groups were asked to take a common test evaluating their learning after the week. The outcome of this experiment was remarkable. Here it is, the histogram of the scores of the two groups, and as we can see, the treatment group outperformed quite clearly the control group. Other dimensions that were also examined, and as it turned out, attendance and engagement were also much superior under the experimental instruction. An important study summarizing the results found in 225 studies was published in the Proceedings of the National Academy of Science a couple of years later. The evidence in favor of active learning is so overwhelming that it forces the authors to state that, had the study been an actual clinical trial, it would have been unethical to continue with the experiment and refuse to give the treatment to the control group. In other words, it is, at this point, morally questionable to continue teaching with conventional methods that do not involve active learning. So, an admittedly simplifying conclusion will be that our way to confront our lectures should be subject to serious rethinking. The learning of basic concepts and theories should probably be delegated to the student. This can be ideally done by creating videos to be watched at home before the actual lectures, or at least by assigning pre-lecture readings. Active learning should then permeate our in-class activities. The roadmap of this transformation involves thus the two main recipes of flipped classroom.